Hi, Intermediate Algebra. I hope you're all doing well, that everybody's getting through the material. I hope you're having a nice day. Okay, so let's start today with 9.6, which is dividing radicals, and I'll put together a couple videos on the lecture for you, and then, as usual, you try the homework and submit it to me. Remember that the college has an online tutoring service, which I would suggest you sign up for, and also you can send me questions. So those are just two really good resources so that you can sort of end the semester in a good, comfortable way. Okay, so for 9.6, the idea that we're going to start with is that when you have a radical, the final answer cannot have a radical in the bottom, in the denominator. So you want to force it out if it doesn't simplify out nicely. So for instance, when I look at this first one, I can't take radical 6, right? I can't take the square root of 6 because 6 is not a perfect square. But I still have to get rid of it. I still have to get rid of the 6 in the bottom. So what I'm going to do is I'm going to give it a twin. Okay, I'm going to give it a twin, and whatever I give to the bottom, to the denominator, I also want to give that to the numerator. So what happens is, by giving it a twin, you make it a perfect square in the denominator, and then that allows it to come out. So then it becomes radical 6 over 6. Okay, so if the denominator just doesn't automatically simplify out of the radical, you have to force it out by giving it the appropriate, if it's a square root, by giving it the appropriate twin. Okay, let's try another one here. So you cannot, the final answer cannot have a radical in the denominator. So radical 10, we can't simplify that. We cannot take the square root of 10. So what you have to do is you have to give it a twin to make it a perfect square. So whatever you give to the denominator, make sure you give to the numerator. So now in the denominator, I've created a perfect square because I can multiply these 10s. So now it's the square root of 100. Square root of 100 comes out as 10. Now this one has an extra step that the other one did not have. If you notice, on the outside, these both have, you can simplify this. So I can take a 5 from the 25, and I can take a 5 from the 10 to make a 2. So whenever you simplify, it has to be a radical with a radical or a non-radical with a non-radical, okay? Since these parts were both non-radicals, I could simplify them. Okay, so the final answer is this. Okay, let's try some more. Now remember, when you look at a fraction, your first thought in your mind should be, can I reduce that fraction? Will that make that easier for me? And when I look at this, there's nothing in common between the 8 and the 27. So the answer to that is no, but that was still like the first thought that goes through my head. So I can't simplify this. So there's two approaches to do this. Some people will make the 27 a perfect square by multiplying it by the correct value, which would be a 3 in this case. Other people will first simplify the radical 27 as much as they can and then get rid of the leftover. So it sort of depends which way you want to do it. So I'll first start by taking out what's perfect in each of them. So for the 8, it's a 4. For the 27, it's a 9. Now I'm going to take out the perfect part from each side. So from the numerator, you're going to pull out a 2. From the denominator, you're going to pull out a 3. Now the thing is we cannot leave the answer like this because it still has a radical in the bottom. There's no problem with the radical in the numerator, you just can't have a radical in the denominator. So I now have to kick that out. So I'm going to multiply up down by radical 3. So in the numerator, I'm going to have 2 radical 6. So since these are both under, you can multiply them. So that becomes a 6. Since these are both under, you can multiply them. So it's 3 radical 9. Because I'm now forcing out the radical 3. And then the radical 9 comes out as a 3. So it's 2 radical 6 over 3 times 3. Right, so just make sure at the very end here you multiply that. So the final answer will be 2 radical 6 over 9. And you just look at the end if you can simplify anything here, which I can't, so I'm done. I just want to say, for some people, an easier technique to that one that we just did, you know, for some people, they would say, okay, well, if 27 is 3 3s, then it's going to just need one more 3 to finish, to be like a perfect square. So some people will first just do that step and make it an 81. Just make it a perfect square, like straight off the bat. And now this will go the top. You do have to simplify at the top. The let's see, 4 is the highest perfect square. The bottom's already a perfect square. Okay, so then some people will just do that. So then they get the 2 radical 6 over the 9. And they just find that technique easier for them. Either way, you get the same answer, so it doesn't matter. So you can make it a perfect square like straight off the bat, or you can simplify it first and then make it a perfect square in the denominator. Whatever order you want to do it in is fine. Just make sure that the final answer does not have a radical in the denominator. All right, let's do another one of these. So for this one, you actually can reduce it first, and I would suggest you do that. So divide out a 6 from both the numerator and the denominator. So if I divide out a 6 from the numerator, that's going to be a 6. Sorry, that's going to be an 11. And if I divide out a 6 from the bottom, from the denominator, that's going to be a 2. All right, so first I just divided both sides by 6. I just reduced what was in here. Now I'm going to simplify out the radical in the denominator. So I'm going to multiply by a radical 2 to both sides. Okay, and then we can get rid of it because I've made the denominator a perfect square, so it's going to come out as a 2. So the final answer here is radical 22 over 2. Okay, so I took out all the perfect squares. There's no perfect squares left in the numerator, and there's no radical left in the denominator, so it's simplified completely. Okay, I will do a couple of videos for this section, but I'm almost about done with this one. Okay, let me just get this to focus. Okay, so just like before, if you have 2 radicals that are being multiplied, you can combine this underneath. Now, you could say 55 over 10, or you could just reduce this right away. My brain just wants to reduce this right away. So now I have radical 11 over 2, which for a lot of us, you like to break it first so you can see it better. So you get that. Okay, so you cannot have a final answer with a fraction under a radical. And once you break it, you cannot have a final answer with a radical in the denominator. So now I'm going to make the denominator a perfect square. So that it simplifies out. And that's that. That's the final answer then. Okay, that's it for this video. I'll pick up and do another one. Bye-bye.